Welcome to Apu Smart YouTube channel. Today on this lecture video we see the grade 9 physics subject. Grade 9 physics subject starts on its unit 1 vectors or a vector quantity. You know that the body which can be measured can be expressed by two ways. The first one is maybe a measured body can express by only its magnitude or size, or maybe a measured body can be expressed by both magnitude and the directions. Now, if the measured body or a physical quantity can be expressed by both magnitude and the directions, you call it a vector quantity or vectors. But if it can be expressed by only its magnitude or size, and if it have no directions, that physical quantity is a scalar quantity. Okay, vector quantities are quantities which express by both magnitude and the directions. Vectors are a quantity which expressed by both magnitude and the directions. Let's see a physical quantity such like a force, acceleration, weight, velocity, okay, let's see a measured body or a physical quantity such like a force, acceleration, weight, velocity, and the momentum looks like physical quantities are a physical quantity which expressed by both their magnitudes and the direction. So there are vector quantities. This vector quantity can be represented by using vectors can be represented by a bold-faced letter, or they can be represented by using arrows on their heads symbol, or on their symbols by using or putting arrows. You can represent a physical quantities. For example, where you can be expressed the force physical quantities, you represent it. Its symbol is F to make it, or this vector quantity or this force can be a vector we using the arrow on its edges, or we can be writing as a bold face. Addition and the subtraction of vectors. We can combine two vectors together depending on their directions. Two vectors can be added together, or two vectors can be one vector can be subtracted from one vectors depending on their directions by different ways. If you take that the vectors cannot be added as a scalar quantity since they have directions, we cannot be using the ordinary algebra while you can be adding together the vectors. We use the graphical way of method of adding the vector combined to each other by using graphically or analytically. See that one vector can be represented by both direction and the magnitude. We see that, for example, if this one is a force which is equals to 4 Newton, this length is the magnitude of that vector, and this is the direction of that vector, Depending on its directions, we can be combined if it is more than two or more vectors. Depending on their directions, we can combine them. For example, if it can be given as example, if two vectors such like force 1 which is equals to graphically 2 Newton in east direction, and force 2 is 4 Newton in east direction. Simply you can be adding these two vectors each other. If this one is force 2, depending on their directions. The magnitude cannot be affect their resultants, but if their direction is similar, you can be directly add the magnitudes. If their direction is not the same or not similar, you can be change into the same directions. Now the resultant vector, which is equals to force 1 plus force 2, is directly given as force 1 is 2 Newton in east directions plus force 2 is 4 Newton in east directions. Now the direction of the two vectors are similar. You can be take a common. So in east directions, since they have the same directions, you can simply add their magnitudes. Their magnitude is 2 Newton and 4 Newton. Simply this one is 6 Newton in east directions. That means the resultant of two vectors, force 1 and force 2. But if their direction is not the same, if they are different in directions, depending on those directions, take that force 1, which is equals to 2 Newton in west direction, and another vector force 2, which is equals to 4 Newton in east direction. Their direction is not similar or not the same. You must change this direction in similar, or change them one to another, or this force into east or this force into west. Their direction must be similar to be add them. Now force 1, which is equals to 2 Newton in west direction, means that equal to the negative of 2 Newton in east direction. So that means the opposite of these 2 Newton force in west direction is equal with, while you can be changed in direction, it is a negative 2 in east directions. And that means force 2 is 4 Newton in east direction. Now their direction is the same. Similarly, you can be add their values. The resultant force, which is equals to force 1 plus force 2, gives minus 2 Newton in east direction plus 4 Newton in east directions. Then, since the direction is the same now, we can be converted into the same directions in east direction, and their value is minus 2 plus 4 gives for you the 2 Newton in east directions. 2 Newton in east directions. Another one is if they can be perpendicular to each other. Now, in these cases, these two vectors on the first example, force 1, which is equals to 2 Newton in east direction, and the force 2, which is equals to 4 Newton in east direction, is parallel to each other. If they are parallel to each other, we can be take the directions and we simply add their magnitudes. This one is if they are parallel to each other. If two vectors can be parallel to each other. On this, the second example, see that this one is 2 Newton in west direction and this one is 4 Newton in east direction. Since their direction is opposite, they are anti-parallel each other. Here, two vectors can be anti-parallel. Another, on third one, if two vectors can be perpendicular to each other, like that. If they are perpendicular to each other, that means two or more vectors. If one vector is perpendicular to another vector, take that this one a force 1, which is equals to 3 Newton, and this one take as force 2, which is equals to 4 Newton. This force 1 is 3 Newton in this, take that in north direction, and force 2 is 4 Newton in these east directions. They are be perpendicular to each other. The resultant means that this one, the resultant of vector is this one. So this one is the resultant vector, which is equals to force 1 plus force 2. Force 1 plus force. On mathematics or on calculus, we know that the right angle triangle rule. Right angle triangle, if this one is the angle theta, and this one is the opposite of that angle, and this one is the adjacent of that angle, this one is the hypotenuse one. Now apply this one on this right angle triangle. We know that the hypotenuse skate, which is equals to adjacent skate plus opposite side skate. That means Pythagoras theorem. Let's see that in right angle triangle, we know that the hypotenuse side scale is equal with the adjacent side scale plus opposite scale. Now apply that Pythagoras theorem here. Since they are perpendicular to each other, this one is the opposite side for this angle, and this one is the adjacent side. That means force 1 is the opposite side for this one, and force 2 is the adjacent side for this angle, and the resultant is the hypotenuse of this angle theta. Depending on this one, the resultant skate, according to Pythagoras theorem, resultant skate is equals to force 1 skate plus force 2 skate. That means the resultant is equals to the radical of force 1 skate plus force 2 skate. So you can be substitute the values, which implies that force 1 is 3 Newton skate plus force 2 is 4 Newton skate, which is equals to under radical of 3 Newton skate means that 9, 4 Newton 4 skate means that 16. Well, you can be adding them, it is 25 Newton skate. That means 5 Newton. Resultant force 1 plus force 2, which is equals to 5 Newton. If there are not parallel, if they are not anti-parallel, if they are not perpendicular to each other, you can be using a triangle rule and parallelogram rule to adding two vectors to each other. Assume that in triangle rule, for example, adding two vectors by using triangle rule, take that if this one is a vector A and this one is a vector B, force A have this magnitude and in these directions, force B have this magnitude and in these directions. By triangle rule, the summation of two vectors is this one, or the resultant of two vectors is this one. Depending on this triangle rule, this one is the head of vector A, this one is the tail of vector A, this one is the arrow shows that the directions, and this one is the head of vector A. Here this is the tail of vector B, and this one is the head of vector B. Two vectors, vector A and vector B, can be combined to each other. Tail to head, tail to head. That means tail vector A, head vector A, vector B's tail, vector B's head. This one is the see that according to triangle rule, you can be add vectors together. Now let's see vector A. This one is tail of vector A. This is head of vector A. Here this is tail of vector B. Here it is head of vector B. Now this one is the resultant. According to triangle rule, if two vectors can be combined together from tail to head, take that vector A plus vector B and assume this one as a vector C. Plus vector C gives that if the triangle is a closed loop, assume this one is a closed loop, if it is a closed loop, the summation of all three vectors is equals to 0. Vector A plus vector B, then vector C, their summation can be given as 0. This means that vector A plus vector B, which is equals to 0 minus C, is minus vector C. So now according to this triangle rule, we get from closed loop the summation of all vectors is 0. Vector A plus vector B gives this vector C. This means that vector A plus vector B, the resultant must be a resultant of vector A plus vector B, which is equals to vector C in opposite directions. This negative shows that the opposite direction. So we say that this is the direction of vector C. If two vectors are combine each other from tail to tail, assume that if this one is a vector A and this one is a vector B, they can be combined together from tail to tail. In this case we can use the parallelogram rule. Take is that a parallelogram rule, apply that. This one is a parallelogram. You can make it. This is the diagonal of this parallelogram. Two vectors which can be combined to each other from tail to tail. We can add them by a parallelogram rule by using a parallelogram. Okay, two vectors which can be combined to each other from tail to tail. Assume that vector A, tail of vector A, and here tail of vector B, and this one is head of vector B. They combine each other tail to tail. Take that this diagonal of this parallelogram. This one is a diagonal of parallelogram. If two vectors can be combined to each other tail to tail, you can be adding them by using a parallelogram rule. We use to adding the two vectors which can be combined together tail to tail. So you know that how you can be find the diagonal of a parallelogram. Using that, the way of finding the diagonal of a parallelogram, find that the resultant of two vectors A and B. That means the diagonal of this parallelogram means that it is the resultant vector which is equals to vector A plus vector B. You can find that እዚህኛው ክፍል ፊዚክስ የመጀመሪያ ምዕራፍ ላይ ያለው ቬክተርስ የሚል ቶፒክ ነው። ቬክተርስ ወይ ደግሞ አንድ የተለካ አካል ፊዚካል ኳንቲቲ የምንለው በፊዚክስ ለክተን ስንገልጻቸው ወይ ደግሞ ስናስቀምጣቸው አንዳንድ ፊዚካል ኳንቲቲን በመጠን ብቻ ማስቀመጥ እንችላለን። አንዳንድ ፊዚካል ኳንቲቲዎች ደግሞ በመጠናቸውና እንደዛውም በአቅጣጫቸውም ጭምር በመጠንና በአቅጣጫም ጨምረንበት የምናስቀምጣቸው አሉ። መጠንና አቅጣጫ ያላቸው ፊዚካል ኳንቲቲዎች ቬክተርስ ይባላሉ። ሶ ቬክተር ኢዝ ኤ ኳንቲቲ which can be expressed by both magnitude and directions መጠንም አቅጣጫም ያላቸው ለምሳሌ እና ፎርስ አይነት፣ ጉልበት፣ አክሰለሬሽን አይነት፣ ዌይት አይነት ፊዚካል ኳንቲቲ፣ ቬሎሲቲ እና ሞመንተምን የመሳሰሉት ፊዚካል ኳንቲቲዎች ሲቀመጡ ወይ ደግሞ ለክተን ስናስቀምጣቸው በሁለቱም በመጠናቸውና ከናቅጣጫቸው ማስቀመጥ የምንችለው የኳንቲቲ ናቸው። ሲምቦሊካሊ ስናስቀምጣቸው ወይ ደግሞ ስንገልጻቸው ቬክተር መሆናቸውን ለማሳየት ወይ ደግሞ ስካላር ከሆኑት ወይ ደግሞ በመጠን ብቻ ከሚቀመጡት ለመለየት ሲምቦላቸው ላይ ወይ ደግሞ ምልክታቸው ላይ አሮ እናስቀምጣለን። ሲምቦላቸው ላይ አሮ ያለው ወይ ደግሞ ሁለትና ከዛ በላይ የሆኑ ቬክተሮች አንድ ላይ መደመር ወይ ደግሞ አንዱን ከአንዱ ላይ መቀነስ እንችላለን። ይህንን ግን ስንደምራቸው ወይ ደግሞ ስንቀንሳቸው እንደ ስካላር እንዲሁ ኦርዲናሪ ወይ ደግሞ በምናውቀው አልጀብራ አይደለም የምንጀምራቸው ወይ ደግሞ የምንቀንሳቸው። ዳይሬክሽን ስላላቸው አቅጣጫቸው ላይ ዲፔንድ ሆነን ወይ ደግሞ አቅጣጫቸውን እያየን ተመሳሳይ አቅጣጫ ያላቸው ወይ ደግሞ ተቃራኒ አቅጣጫ ያላቸው አቅጣጫ ላይ ዲፔንድ ሆነን በተለያየ ሜተድ ሪዛልታንት ሆኖ ወይ ደግሞ ኔት ፎርስ ሪዛልታንት ሆን ወይ ደግሞ የሁለቱ ቬክተሮች ሪዛልታንቱን ማስቀመጥ እንችላለን። ለምሳሌ እዚህ እንደምታዩት ይሄ ፎርስ ተሰጥቷል 4 ኒውተን ነው። ይሄ ዲያግራም የሚያሳየው ማግኔቲዩድ ነው። እቺ አሮ የምታሳየው ዳይሬክሽን ነች ወይ ይሄ አሮ የሚያሳየው ዳይሬክሽን ነው። ሁለት ቬክተሮች በፓራላል መልኩ ወይ ደግሞ ተመሳሳይ ወይ ትይዩ በሆነ ዳይሬክሽን ካሉ ለምሳሌ ይሄ 2 ኒውተን በዚህ በኢስት ዳይሬክሽን እና ቬክተር 2 ደግሞ መጠኑ 4 ኒውተን በኢስት ዳይሬክሽን ካለው ትይዩ የሆነ ዳይሬክሽን ስላላቸው ደግሞ ፓራላል ስለሆኑ ተመሳሳይ ዳይሬክሽን ያላቸው ቬክተሮች ስንደምራቸው አንድ ላይ ተመሳሳይ ዳይሬክሽን ስላላቸው መጠናቸውን ብቻ አንድ ላይ እንደምራለን ማለት ነው። ስለዚህ 6 ኒውተን ኢን ኢስት ዳይሬክሽን እናገኘዋለን። ሌላኛው አንቲ ፓራላል ከሆነ ተቃራኒ ከሆነ ዳይሬክሽን ናቸው። ለምሳሌ ይሄ 2 ኒውተን በዌስት ዳይሬክሽን እና ፎርስ 2 ደግሞ 4 ኒውተን በኢስት ዳይሬክሽን አለን። ተቃራኒ የሆነ አቅጣጫ ስላላቸው ወደ ተመሳሳይ አቅጣጫ ማመለስ አለብን። ወይ ይሄንን ወደ ኢስት ወይ ደግሞ ይሄንን ወደ ዌስት መልሰን እንደምንደምራቸው አንድ ላይ ስንደምራቸው ሪዛልታንታቸው ወይ ደግሞ ቶታል ኔት ፎርሱ የምናገኘው ይሄንን ስንመልስ 2 ኒውተን ኢን ዌስት ዳይሬክሽን ሚንዛት የሱ ተቃራኒ ብንወስድ ወደ ቀኝ ካል ተቃራኒ ወደ ግራ ይሆናል። የሱን ተቃራኒ ብንወስድ ለምሳሌ 2 ኒውተን ኢን ዌስት ዳይሬክሽን ማለት ኔጌቲቭ 2 ኒውተን ኢን ኢስት ዳይሬክሽን ማለት እንችላለን። ለማመሳሰል ኔጌቲቭ 2 ኢን ኢስት ዳይሬክሽን ማለት እንችላለን። ይሄ ከዚህኛው ከ2 ኒውተን ኢን ዌስት ዳይሬክሽን ጋር እኩል ነው። ስለዚህ አሁን ይሄንን ስንደምራቸው ወደ ተመሳሳይ አቅጣጫ አምጥተናቸዋል። ኢስት ዳይሬክሽን ዘ 4 ሲቀነስ 2 ወይ ደግሞ ኔጌቲቭ 2 ላይ 4ን ስንደምር 2 እናገኘዋለን። አንቲ ፓራላል ከሆኑ ደግሞ ወይ ዳይሬክሽናቸው ተቃራኒ ከሆነ በዚህ መልኩ እንፈልገዋለን ማለት ነው። ሌላኛው ፐርፔንዲኩላር ከሆኑ ነው። ሁለት ቬክተሮች ፐርፔንዲኩላር ከሆኑ ወይ በተለያየ ዳይሬክሽን ካላቸው ፎርስ 1 ለምሳሌ በዚህ ኖርዝ ዳይሬክሽን ካለና ፎርስ 2 በዚህ በኢስት ዳይሬክሽን ካለው እነኚህ ሁለቱም ቬክተሮች አንድ ላይ ስንደምራቸው ሪዛልታንታቸው ይህንን እናገኘዋለን። ይህንን ደግሞ ትራያንጉላር ሜተድ ተጠቅመን ራይት አንግል ትራያንግል ላይ እቺ አንግል ቴታ ከሆነች እና ይሄኛው የዚች አንግል ቴታ አድጀሰንት ከሆነ ይሄኛው ሳይድ የዚች አንግል ቴታ ኦፖዚት ከሆነ ሃይፖቴነስ ወይ ደግሞ ትልቁን ሳይድ ስንፈልግ ራይት አንግል ትራያንግል ላይ ሃይፖቴነስ ስኩዌር ኢዝ ኢኳልስ ኦፖዚት ስኩዌር ፕላስ አድጀሰንት ስኩዌር ይሆናል። በዚህ መሰረት የዚህንን ሪዛልታንት መፈለግ እንችላለን። ከዛ በኋላ ይሄ ሪዛልታንት ዳይሬክሽኑ እንዴት ይሆናል ወይ ደግሞ ይሄንን ሪዛልታንት ዳይሬክሽኑን በየት በኩል ወይ ደግሞ ዳይሬክሽኑን እንዴት እናስቀምጣለን? መጠኑን በዚህ በፓይታጎረስ ቲዮረም ፎርስ 1 ስኩዌር ፕላስ ፎርስ 2 ስኩዌር አንደር ራዲካል ብለን እንፈልጋለን። ዳይሬክሽኑ እንዴት መፈለግ እንችላለን የሚለው እዚህ ጋር እናያለን። ዳይሬክሽኑን ስንፈልግ የዚህን የሪዛልታንት ቬክተር በፐርፔንዲኩላር ቱ ኢች አዘር ከሆኑት ስንፈልግ the direction of two vectors which can be parallel to each other, perpendicular to each other, and the resultant of two vectors which can be perpendicular to each other, force 1 ስኬድ ፕላስ ፎርስ 2 ስኬድ ይሄ ማግኒቲዩዱ ይሆናል። የዚህን የሪዛልታንት ቬክተሩን ዳይሬክሽን ስንፈልግ ምንድነው የምናደርገው? የዚህችን አንግል ወይ ደግሞ የዚህችን አንግል ታን እንፈልጋለን። that means the tan of theta is equals to opposite over hypotenuse ነው force 1 over force 2 if force 1 is perpendicular to force 2 then this theta is equals to tan inverse of force 1 over force 2 ይሆናል። ስለዚህ እቺን አንግል ካገኛችሁት የዚህ የሪዛልታንቱ ወይ ደግሞ የሁለቱ ፎርሶች ድምር ዳይሬክሽን ይሆናል ማለት ነው። ዳይሬክሽን ይሆናል if two vectors are perpendicular to each other the magnitude of the resultant can be determined by this and the direction of that resultant vector can be obtained by tan theta which is equals to force 1 over force 2 then theta is equals to tan inverse of this value አሁን ደግሞ ሁለቱ ቬክተሮች በትራያንጉላር ሩል ሜተድ ድምራቸውን ወይ ደግሞ ሪዛልታንት ቬክተራቸውን መፈለግ እንችላለን። ለምሳሌ ቬክተር ኤ እና ቬክተር ቢ ሄድ ቱ ቴል የሚገናኙ ከሆነ ኤ ቬክተር ኤ ሄዱ ቴሉ ይሄ ነው፣ ሄዱ ደግሞ እዚህ ጋር ነው። ከሱ ቀጥሎ ቬክተር ቢ ቴል ኦፍ ቬክተር ቢ ሄድ ኦፍ ቬክተር ቢ ይህንን እንዲህ የተሰጡ ሁለት ቬክተሮች ፐርፔንዲኩላር አይደሉም፣ ፓራላል አይደሉም፣ አንቲ ፓራላል አይደሉም። እንዲህ አይነት ቬክተሮች ዳይሬክሽናቸውን እና የድምሩን መጠን ስንፈልግ ሪዛልታንት ቬክተሩን ትራያንግል ሩል ተጠቅመን ነው የምንፈልገው። ትራያንግል ሩል ስንጠቀም ይህንን እንጨምርበትና በትራያንግል ሩል የሶስቱ ሳይዶች ድምር ቬክተር 0 ይሆናል። እቺን ሲ ብለን ሰይመናታል። እቺ ሲ የቬክተር ኤ እና የቬክተር ቢ ድምር ነች ማለት ነው። a plus b plus is equals to 0 according to the triangle rule. That means a plus b is equals to 0 minus c means that minus c. A plus b is equals to the resultant of a plus b is equals to minus c. This minus or which negative ምንድን ነው የምታሳየን? a vector ዳይሬክሽኑ ለምሳሌ እንዲህ ብንወስድ የዚህ ዳይሬክሽኑ ተቃራኒ ይሆናል ማለት ነው። ኔጌቲቭ ስለሆነች ዳይሬክሽኑን ነው የምታሳየን ኔጌቲቭ። ሌላኛው ደግሞ ቴል ቱ ቴል የሚገናኙ ከሆነ ቴል ቱ ቴል ሁለቱ ቬክተሮች ቴል ቱ ቴል ቴግዛት ቬክተር ኤ ከዚህ ተነስቶ እስከዚህ ቴል እዚህ ጋር ነው። ቬክተር ቢን በዚህ መልኩ ከተሰጠና ቴሉ እዚህ ጋር ከሆነ ሁለቱ ቬክተሮች ቴል ቱ ቴል የሚገናኙ ከሆነ ፓራሌሎግራም ሩል የሚባል ተጠቅመን ድምራቸውን ወይ ደግሞ ቶታል ሪዛልታንት ቬክተሩን መፈለግ እንችላለን። ዘን ቬክተር ኤ ቬክተር ቢ ቴግዛት this as a vector b prime, this as a vector a prime. That means the image of a, this one is the image of b. Then this one looks like a parallelogram. ምስል እንደምታዩት ፓራሌሎግራም ይመስላል። ከዚህ ከፓራሌሎግራሙ ላይ ዲያጎናል መፈለግ ትችላላችሁ። ዲያጎናል ኦፍ ፓራሌሎግራም እሱን ስትፈልጉ እናንተ ዲያጎናል ኦፍ ፓራሌሎግራም እንዴት እንደምንፈልግ ሂሳብ ላይ ታውቁታላችሁ። ያንን ተጠቅማችሁ የዲያጎናሉን ስታገኙት ዲያጎናል ኦፍ ዚስ ፓራሌሎግራም ጊቭስ ዘ ሪዛልታንት ኦፍ ቱ ቬክተርስ የቬክተር ኤ እና የቬክተር ቢ ቶታል ሪዛልታንት ወይ ደግሞ ኤፌክቲቭ ሪዛልታንቱን ይሰጣቸዋል። በዚህ መልኩ ፈልጉ።